Hello guys, welcome to another video. Today we're going to be looking at the calculus, and this is part of the calculus playlist. We're going to be looking at the most fundamental rules for differentiation, and we're going to be looking at derivatives today. So first we have the sum rule, right? We're going to be looking at the sum rule. Now here we have the sum rule. So what we're going to be doing with the sum rule is just looking at a quick example. It's pretty easy. Basically, the derivative of the sum is the sum of the derivatives. Right, so if we had two functions, 2x squared and 3x in one function, if we wanted to do this, we would just take the derivative. Now, this video, we're going to be assuming we know the basic rules of derivatives, the power rule, basically. So when you take the derivatives, it will be 4x plus 3, because you take this and you take this and add them together. Now, time to move on to the product rule. Now, the product rule is similar, however, there's a slight catch. Now, here shown is the product rule. Basically, we're going to be looking at an example once again. In this case, it's when two products are multiplied. We have the derivative of one of the functions times the other, plus the derivative of that second function times the first. Let's give an example. Let's say something like 2x times x plus 2. Now you could expand this, but we're not going to. We're just going to do it normally. And what we're going to be doing here is simply applying it straight away. So the derivative of 2x is 2 times the function x plus 2 plus the derivative of x plus 2, which is just 1 times 2x. And therefore we have 4x, right? Yep, 4x and a 4. That's our function for the product rule. Now, time to look at the chain rule. One of the most important rules is the chain rule for composite functions. Now, here we have the chain rule written out. The derivative of f of g of x is the df over dg times dg over dx, or f prime of g of x times f prime of x. Now, basically, it's derivative of f with respect to g and times derivative of g with respect to x. Let's look at an example. We're going to be using the famous e. So d over dx of something like e to the 3x plus 2. Now this is, right, simply applying the chain rule. This is g of x and e to the x is f of x, right? So what we're going to be doing is simply applying it. What we can do here is change it, the form, right? Because since we're doing f prime of g of x, that's e to the 3x plus 2, it doesn't change. Now, of course, we multiply by the f prime of x inside. So what's the derivative of 3x plus 2? That is simply going to equal to 3, right? So it'll become this. And that is the chain rule covered. I'm going to go over one more example because the chain rule can actually be extremely useful. Let's say we have this, right? Instead of expanding it, which would take so long, we can use the chain rule again, right? We can derivate the outside using the power rule. So we have 3 times 2x plus 3 squared. You can just imagine this as like x and then derivative that. Then take the inside and take the derivative of that, which is going to be 2. So we 2 times that, we get 6, which is wonderful. We have this expression, which is easier to expand, and you can just leave it like this too. Now the next rule comes out of the quotient rule and the chain rule, which is the product rule. I'm gonna state it. Sorry, not the product rule. Yeah, the quotient rule comes out of the product rule and the chain rule. Now I'm just gonna have a bit time writing it out. So the quotient rule is f of x over g of x, and this is going to equal to f prime of x. It's a shortcut way. It's gonna take too long if I write it the other way. Times g of x minus g prime of x times f of x. And because of that, what you can do, there's also a over gx squared. What you can do is instead apply this in cases where the quotient rule wouldn't be too good. However, be cautious, because something like if you cosine x over x, if you want to take the derivative of this, it'll be much easier to do this and use the product rule than do this, because this is more complicated than the product rule. But in case it's something like this, it's extremely hard to write it as x minus 1 to the negative 1. Then you have to apply the chain rule and then the product rule, which is more complicated because it forms the quotient rule. And that's why you should use the quotient rule sometimes. Now we're going to be looking at some cooler things using this property, one of the most fundamental properties in calculus and of the number e, to prove something. This, which might be a lot more useful than you think. Let's try and do this, right? Now the key thing is to write it so it has a base of e, if you know what I mean. Now we've covered the other rules. We should be able to do this using them as well. So a can be represented as e to the power of natural log of a. Now most numbers can be written in this form if you just put that inside. We're doing a positive basis, just for information. Now this, we have to put it to the power of x, right? Now using simple exponent properties, I'm sorry, I forget to write this sign. Using simple exponent properties, we have that it is like so. E to the x times natural log a. Now what we can do after this is simply a bit of manipulation, right? We can just manipulate it so that it's using the chain rule. E to the x ln a times the derivative of the inside, which is a constant ln a, chain rule. Now after this manipulation, using the actual derivative properties, we can rewrite this. This is basically the same thing. I'm just writing it so this is slightly clearer too. So you have this to the power of x again, right? You're raising this to the power of x. You're taking it out. We're undoing the step after the chain rule. And if you notice, this is actually just a from before, of course. So we get a to the x ln a. We have simplified it. Therefore, this is another rule you should know. Derivative of a to the x is going to equal to a to the x times the natural log of a. Time to do a similar one where we have log base a of x. We want to take the derivative of this. How do we do that? Well, it's pretty similar. We start off with another fact, is that the derivative of the natural log of x is equal to 1 over x. And as you might have guessed, we are going to use a change of base formula to really calculate this. How can we do that? Here I show you. Okay, so basically, natural log of x is this. Right, now using the base change, using the base change formula, what we can do is change this base e into something else, right? Just keep this in mind for now. Okay, let's look back at our problem. We have this. We are taking the derivative of this. We can change it to 1 over natural log of a times the natural log of x over here, right? Now, this is just the other representation. Now, just sign on, this is using the change of base, right? Because the change of base changes, so the top needs to be x and a is the bottom. Now, after doing this, you should be familiar with change of bases. If not, you can look up how to do change of bases. Anyways, this is a constant, so when we are derivating, sorry about the messy landscape of my work, when we're taking the derivative of this, we can bring this constant out. Right, so we end up with 1 over the natural log of a times the derivative of the natural log of x. And this is just easy now. We have 1 over x ln a, which is pretty similar to what we've seen just now. So this is the derivative of log base a of x, which is very useful in many situations in calculus. Now there's this last thing in our little 10-minute video about inverses. Basically, what we can do is write it this way. If you have a function f and g, which are inverses, what you can do is use this. F prime of x, the derivative of f, is equal to 1 over the derivative of g of f of x. Similar to the chain rule, the split, but not quite. Now this is very useful in many situations. I'm not going to show you one here, but if this video gets many views, I'll prove it to you guys. but this is the rough idea. And thank you guys for watching this 10-minute video about calculus rules, and hope you enjoyed it.